Now, let's talk about an ellipse now. Now, with an ellipse, you're going to have something called foci. So, an ellipse is actually the set of points in a plane whose distances from two fixed points in the plane have a constant sum. And the two fixed points are called the foci of an ellipse. Okay, to show you this, here's an ellipse, and notice that this point right here is a focus. So we'll call it F1. And this point here is another focus, and we'll call it F2. Well, if you'll notice that this point on the ellipse, this point 0, 2, if you were to measure the distance from this focus to this point, and then measure the distance from that point to the other focus, and add them up, you'd get a sum. Let's call that sum K. Well, if you pick another point on the ellipse, and you got the distance from this focus, and then from the point to this focus, and you added those two up, you would get the same value, K. And that's true for any point on the ellipse. So if you go to this point, and you took the distance from this focus to that point, and the other focus to that point, and added them up, you would get that same number, K. So in other words, every point on here, if you add up the distance from the point to each of the foci, they're going to add up to the same number. And so that's what that definition is telling you. Okay, now the points where the focal axis and the ellipse cross are called the ellipse vertices. So the vertex, one vertex here is the point -3, 0, and the other one is the point 3, 0. Okay, because this is called the x-axis is called the focal axis, and then here over here you have a vertical focal axis, and so the vertices here are the points 0, -2, and the point 0, 2. Now we'll talk about how I got that information in just a minute. So basically, the standard form for ellipses centered at the origin. Now, if you want ellipses centered at some other point, you can write the equation by using the transformation formulas. But let's say you have x squared over a squared plus y squared over b squared, where the denominator of the x squared term, the a squared, is the larger value. In other words, a is greater than v. Well, to find the distance from the center to the focus, that would be, c would be the square root of a squared minus b squared. So the foci would be plus or minus c 0. And then the vertices would be the points plus or minus a 0. And so the semi-major axis would be a, and the semi-minor axis would be b. So an example of that would be x squared over 9 plus y squared over 4 equals 1. Now notice that if you take the square root of 9, this denominator, you get 3. So this is actually 9 is 3 squared. And if you take the square root of 4, you get 2. So b is actually 2. So this has to be a squared since it's bigger than this term. So a would be 3 and b would be 2. Well, from the center from the focus, using this formula up here, would be the square root of 9 minus 4, a squared minus b squared, which would be the square root of 5. So that tells me that the foci are plus or minus the square root of 5, 0. Well, I didn't label them here, but I did label them with F1 and F2. So F1 is minus square root of 5, 0, and F2 is plus square root of 5, 0, and that's the foci. Now the vertices are actually plus or minus a 0. So a is 3, so the vertices are plus or minus 3, 0, which you see labeled here and here. Now, so the semi-major axis is 3 units from the origin. So in other words, it's 3 units to the right, 3 units to the left. So it's this line here. And the semi-minor axis is 2 units from the origin, and that's just because b is 2. So if you go up 2 units from the origin and go down 2 units from the origin, then you get these points 0, 2 and 0, minus 2. and that's the ellipse. Now again, these are for ellipses that are centered at the origin. These vertices and foci change if you're centered at somewhere other than the origin. Okay, if you have the foci on the y-axis, then the denominator of the y-squared term is going to be larger. So an example of that, and then c would be the square root, still would be the square root of a squared minus b squared, because we're saying that a squared is always the larger term. So, and again, so the foci now, if the foci are on the y-axis, the foci would be x equals 0, but y would be plus or minus c. And the vertices would be x equals 0, and y would equal plus or minus a. And the semi-major axis would still be a, and the semi-minor axis would still be b. So an example here, notice here the denominator of y squared is a larger number. So a squared would be 4, so a would be 2. B squared would be 1, so b would be 1, the square root of that. And then c would be the square root of a squared minus b squared, which is 4 minus 1, or the square root of 3. So this point here would actually be the point, this point would be the point 0 square root of 3, and that's one of the foci. And then this point down here, which actually you can't see it because it's hidden behind this, is the point 0 minus the square root of 3. And so that's the two foci. That's a 3. Okay, and then the vertices are the point 0, 2, and 0 minus 2. So that would be this point here and this point down here. Well, since the semi-minor axis is b, that would be 1. Then you go 1 unit from the origin to get this point, and then 1 unit to the other way from the origin to get this point, and you get the semi-minor axis that goes through these points. So the semi-major axis goes through these 2 points, and the semi-minor axis goes through these 2 points. And anyway, basically, once you have these 4 points, you can draw a rough sketch of the ellipse. Okay, so you can do this as a practice problem. Identify the center, the vertices, the foci, and the axes, and from there you can get the answers, and then you can check your answers with what I listed below. Now, just for grands real quick, let me just tell you what happens if the center is not at the origin. So let's say that you had basically the same ellipse as we had up here, same ellipse as we had here, but instead of x squared, you have x minus 3 quantity squared. Instead of y squared, you have y minus 1 quantity squared. Well, that would basically just change the center of the ellipse, but it would also change those other points. And so let me show you that. Okay, so I want to attempt to draw this, but basically your center would move 3 to the right, 1, 2, 3, and then down 1. And then this vertex, or this foci would move, this is actually square root of 5. So this would move 1, 2, 3 to the right and down 1. And then this vertice would move 1, 2, 3 to the right and down 1. And this foci would move 1, 2, 3 to the right, down 1. And then this point would move vertice 1, 2, 3 to the right and down 1. And then so would these vertices. They would move 1, 2, 3 to the right and down 1. And then this would move 1, 2, 3 to the right and down 1. So all those points would just move 3 to the right and down 1. And so roughly I'll try to just visualize it here for you. Your ellipse would look something like this. It would go up here and go through here, then go down through here, and then go down through here, and then come back. So basically, when you have an ellipse that's not centered at the origin, you just have to shift all of the points a certain number of units to the right or left, and then a certain number of units up or down to get the new points. Okay, so now let's move on to hyperbolas.